Very much. I'd like to thank Charlie for having invited me. And I must say that when he told me about the subject, innovation, well, actually, it's precisely my current favorite topic. I have other favorite topics, but that's my most favorite topic, innovation. The sentence about change is that change is an opportunity to innovate, and digital impression is providing us an opportunity to move forward. And for me, it was really a revolution in my practice. Obviously, digital is very important in the field of agriculture, industry, but also for us as orthodontists. And it was a matter of moving forward for me, and it matters a lot. I'm going to introduce indirect bonding from a digital impression in the practice. Now, you can do it with a lab, but it's important to understand that you can do it also in your practice. There are three key words: indirect bonding, digital impression, and why in your practice. Indirect bonding is something that I really believe in. I've done almost nothing else for the last 17 years. I'm not going to dwell on the reasons, the rationale. You're all familiar with the rationale, accuracy. You all know that we also want to ensure the patient's comfort, the dentist's comfort, the finishing is also better. And so we all know the rationale for indirect bonding. Digital impression, you all agree with me. It's very important. We see it every day. Now, all of us did hesitate. I did not, but most people hesitated before they bought digital impression scans. The first time I saw an intraoral scan, I was convinced. And for the patient, it obviously improves comfort. It also helps the patient understand the treatment plan because he sees the model immediately. It also allows us to deliver the best possible care. We are more accurate. We can manage our workflow better in the practice. We can store the data. No need to send a plaster model by mail or by delivery company, and it's also improving the treatment. It's the best treatment option for the analysis, but also for the treatments using setups and aligners or positioners. I remember a time when the patient did not wear the positioner and it relapsed, we had to put attachments back in the patient's mouth. Now we don't need to. We can retreat the patient without having to do all this. And I would like to explain to you why this is useful for indirect bonding. Now, my first indirect bonding from a digital impression was made in 2013. That's many years ago because a lot has happened since. I treated the first case in this fashion in 2013. The impression had been made. Taking the impression lasted 40 minutes. It still hurts when I remember it took me 40 minutes. And I said, okay, what do I do with the impression? So I looked for labs that would print the impression for me because at the time I didn't have a 3D printer. And 4 different labs gave me a completely different level of accuracy. It was very random. It went from a very accurate model to something that was simply impossible to use. And the prices ranged from 30 euros to 120 euros. And I started bonding my first case. I've done many since, but that was my first case, and it was difficult. Why was it difficult? Because all the impressions were made of resin. Now, I used a resin model. I was bonding with a composite on resin, and obviously it stuck. So bonding ceramic on a resin model was simply a very bad idea. But I finished by bonding the case, and none of the brackets came off. And that's when I thought, okay, I'm going to have to work on this. This is not easy right now. It took me a couple of years to learn. The very first cases, what were the challenges? Well, the impression acquisition time was very, very long. Also, 3D printing was very expensive. I had to have the impression done by a lab. The cost of the model was very high, and also the material used for impression was not appropriate. There was only resin at the time. But things have changed in the meantime. Things have changed starting in 2015-16 maybe, when low-cost digital impression machines came on the market. The fact that we were able to print in our own office, the fact that new materials became available, no longer resin but other materials, and also the cost of the model went from 120 euros to 60 cents. And I said, okay, let's go for it. So I started focusing on this topic. I gave up traditional impressions. I started bonding from that very day because I finally had the answer to all my questions. Indirect bonding, digital impression in the office. Why in the office? Because I want to be in control of the way I position the bracket. For me, it is the most important step in the orthodontic treatment. Where do I place the attachment? Whether I want to bond it by hand or virtually, I still want to control that particular stage in the treatment. So there are three options. Why three options? Because I have learned a lot since 2016. The first technique is one that you can use tomorrow. All you need to do is buy a 3D printer and you can do it. The second technique, you need a little training. You need a software and you have to learn to use the software. And the third technique, well, is one that I am still working on. So it's not readily usable. I don't have enough information because I'm not ready. Not because I don't want to share the information, because I'm not ready. I will be in 3 months from now. We're working. So first technique is the model impression, model printing. I'm going to explain which printer, how to position the attachments manually on the model, and how to make the aligner very quickly, and then the clinical transfer jig. The second option will require a few months of preparation and learning. It's a virtual positioning, model impression, model printing, and manufacturing of the aligner. And finally, the third one is the direct printing. But I need a few more weeks before I can really be knowledgeable enough about the subject to tell you about it. The first technique, take the digital impression, you print the model, you position the attachments on the printed model, you prepare the positioner, and you transfer. This is something you can do tomorrow. You order a 3D printer and you can do it. The impression for indirect bonding needs to comply with a few features, specifics. Well, first of all, everything starts with the quality of the impression. So you have to work on your impressions because the impression must record all buccal surfaces, no defects, no gaps. But you also have to record all the lingual and occlusal surfaces with no defects, because if there is a defect, there will be a defect in the transfer jig, in the positioner, and therefore your attachments will not be correctly positioned. Second element, you need to record the distal face of the last tooth to be bonded, because this also contributes to the accuracy of your positioner. And also pay attention to the interproximal areas, especially if you're going to use the second and third metal with virtual positioning, because you have to separate the teeth virtually, and therefore you have to be extremely accurate on the interproximal aspect. Finally, it is necessary to take 3 or 5 millimeters of soft tissues in order to visualize the orientation. No more. 3 millimeters are enough, because otherwise the impression time would be too long. But you have to simply be able to see the orientations. So now you've taken the impression, you have to work on the impression to make a model. You have to make a base in a horseshoe-shaped base. What I also recommend is that you work the model in such a way that you cut the model as follows, all around the model. 2 reasons. Quick impression plus manufacturing the aligner will be faster, because the wider the base, the more difficult it is to make the kind of position that I'm going to show you. So you cut all around the model, maxilla and mandible. Next, you have to print the model. Once you have prepared your model, you need to print the model. And now you have to choose the right type of printer. I know that some of you are waiting for this. Obviously, there are many different printers available on the market, but I'll tell you about the ones I know. And I know quite a few, because it's become an addiction. And as soon as a new printer comes out on the market, I want to buy it. And I'm really addicted, and I go and test every single new printer. And I'm going to share everything I know about printers. Comparing 3D printers starts with the material, the accuracy, the printing speed, the size of the printing tray, the cost of the printer, the cost of the model, the size of the printer, because I've had a few surprises. I ordered some printers that ended up being really bulky and big. There is also the user friendliness of the machine, whether it's easy to use the printer, the software, the connections, because if your printer is so bulky that you cannot place it near the computer, you're stuck because you can't connect them together. How easy it is to remove the models from the printer, and finally, it is a lot of information to go through. I will give you a comparative table at the end. We will start with the printer with resin. I'm not excluding resin altogether. I'm not ruling it out. I said initially that resin was a bit of a problem with the very first printers, because I know 3 printers, one of which is this one with resin, and there are 2 different technologies. There is the stereolithography printer type and the light digital analysis, 2 different types of printers. In the digital processing, a layer of resin is deposited, whereas the other system works by analyzing the light and light curing only the model layer. So it's 2 different technologies. Suffice to say that all the printers, none of these printers are suitable for the first technique. You cannot bond on resin models. However, they are suitable for the second technique. And it depends very much on the technique you're going to choose. If you position the attachment on the model, well, forget about this type of printer. The second method, virtual positioning and model printing, yes, you can do it. And in the third method, only this type of printer will be suitable. Filament printers. Filament printers are suitable for the first and second method, but not the third, because they cannot print the model, the positioner itself. I believe that you're going to have both technologies in your office. I'm very familiar with these 4 printers. There are probably others on the market that are just as good, but I'm not familiar with them. There's the Up Plus 2, there's the Zortrax, there's the Rise, and there is Upbox. The type of material that feeds those printers, but there are different types of materials available: ABS, PLA, carbon fibers, nylon, wood. I'm going to tell you about the 2 materials that we can use for dentistry, and with which I must say I do a very good job, ABS and PLA, and even if I had to choose, it would be ABS. With these materials, the model weighs 8 to 10 grams. The coil weighs between 500 and 600 grams. So you end up with a model costing 50 to 70 cents. So we're very remote from the original price of 120 euros. PLA is a biocompatible material. That's the main advantage. However, it starts melting at the temperature of 160 degrees, and you have to work on it at 180 degrees. The filament breaks. It's very brittle, and the printers need to be maintained. If the filament breaks in the nozzle, then you have to clean the machine. So if you're very sensitive to environment, okay, the PLA is good because it's biodegradable, except it means a lot of work for maintenance. And if you want to thermoform on PLA, forget about it, because PLA melts at 180 degrees, your plate arrives at 220 degrees, the model will simply flow and melt. And that's what happens. In the positioners that I'm going to show you, there is no thermoforming on the model, but if you want to use the printer also for a retention model or for aligners, forget about it. So in that case, choose ABS. ABS is a plastic. It's the same plastic that we use for coffee machines. It's not biocompatible, I grant you that. However, you're not going to put it in the patient's mouth anyway. It will become soft at 90 degrees, it starts melting at 180 degrees, and you work it between 230 and 270 degrees. There's the AIM ABS that reaches 270 degrees. So for our positioners, for thermoforming, no problem. It is less brittle than PLA. Take-home message, forget about PLA, choose ABS and a filament printer. Now, but there are many different types of ABSs depending on the supplier. There's ABS, Z Ultra, ABS Plus, and EB ABS, and more. Because we don't have much time, I'm going to zoom in on what you need to use. If you use methods number one, take ABS or ABS+. If you want to use the second method, virtual positioning, then take MABS. Because of the model quality and the results that you can achieve. Z Ultra, I started with that material, but I gave it up entirely because there are small defects on the model which are going to distort the final attachment position. Printers. Now I'm going to make a quick comparison regarding accuracy, the size of the tray, and the speed. On all printers, forget speed because that's only a commercial argument. I have not noticed a notable difference between the printing speed of all 4 printer models. So I would like to focus on accuracy, the dimension, the size of the tray, and compatible materials. But all the printers print all the materials, so I will focus on the first 2 features and the cost. This printer is very quick. It can be used really easily. The software is very easy. You can do just about everything. It's very versatile, but the tray is very small. So on the tray, you can only do 4 models maximum with a horseshoe base. If you have a full base, then only 2 models, 1 patient. So if you're going to use this kind of printer, then buy several. It doesn't go fast enough otherwise. The Zortrax. The Zortrax is more expensive, 2 to 3 times more expensive, because there are different models, obviously, and different sizes. I'm familiar with the medium size, the 2000. Accuracy is 90 microns. The up is 150 microns. I have not seen any difference for the type of things we do. 150 microns for manual bonding is more than sufficient, but it's not suitable for method number 2, where you print the locks. So if you use method number 1, the up is more than insufficient. The advantage versus the previous one is the tray size. It's twice as big. 400 square centimeters, so you can print 8 to 10 models. The downside with this printer is here. I don't know if you can see this. Look at the cuspid tips. They are not accurate. And for indirect bonding, it's a huge problem. But that was my first printer that I bought, so I was very frustrated. And that's the reason why I changed. I switched to another one, the Upbox Plus. Now, all the printers can be used 24 hours a day. I use them 24 hours a day, or almost. They can all be used for a very long time. For indirect bonding, I give you the main advantages. 100 microns, same software as the up, same manufacturer, except the tray size is 2.5 bigger than the up plus 2. And all materials can be printed, at any rate the ones I want to use with this particular printer. We can print 9 to 12 models, so we initially had 4, now 8, now 12. More comfortable. But again, it can be used, it's suitable for method 1, but not method 2, because it's not accurate enough for the attachment to be well designed. And if you print with this kind of printer, with the attachments on the model, there is a lot of material on the attachment that goes onto the attachment, and you damage the attachment when you want to remove the material. The raise. 3 sizes, forget about the big one. The big one is useless because we are using relatively flat models. The 1 and 2 are the ones I know. I'm more familiar with the N2, but I guess that the finishing is the same. The advantage is that we have up to 10 microns of accuracy. It is more or less the same price, although it's a bit more expensive, but there are 2 different sizes. I mean, the tray size is twice that of the previous one. So we can print up to 20 models if you lay them flat, and if you position them vertically, then you can print 30 models in one go. Fabulous, except there are also downsides. Here you see the size. It's bulky. So again, I've had a few surprises where I ordered a few printers, and when they were delivered, I found they were so bulky that I didn't know where to put them. And so these are the 2 comparative tables. remember that if you focus on accuracy, the best is raise 3D and 2, 10 microns. The only one suitable for method number 2, virtual positioning and model printing. If we focus on cost, obviously it's not the same price. But with the bigger ones, you make more models. If you talk about the cost per model, the same. And if you talk about the tray size, well, the worst one is A+2, very small tray. And speed, material, again, they're all comparable. If we compare user-friendliness, I would rule out Zorkraks because the connections are very, very fragile. We had to change the cables several times, and also the tray. The raise has one downside. It's not very user-friendly. It's not difficult, but you have to learn. The software is quite complex. There are many different options in the software, so we have trouble finding our way around the software. You have to learn the software before you can use it. This is it for the comparison between the filament printers. So once we've made the impression, we have prepared the model, we position the attachments according to method number 1. Here we have your normal measurement tools, and you can bond the attachments on the model. Which insulating material? Well, none, because we've chosen a filament printer. So all you do is take the attachments and bond it with the composite. There is no interaction between the composite and the ABS that you are using to print the model. Position the attachments, load them and position them on the model. No insulating varnish is needed, nothing deposited on the model. You position the attachments and you have as much time as you want because the model is opaque. More accuracy, we reach the temperature at which the plastic becomes soft. And do we need to use an insulating material? Of course not, because you're going to contaminate the composite. Also, on the model, when you thermoform on such a model, or the white one or the green one, what happens? When we used plaster models, the model was both stiff but porous, so air would go through the plaster. In the silicone model, the model is very flexible, but the air goes through, whereas on an ABS plastic model, which is completely opaque, no porosity, very stiff, there are air bubbles because air could not go out. So we lose everything because the attachments are not retained by the positioner. We lose the attachments and we lose all the benefits of indirect bonding. So it was necessary to find a solution and find a new type of positioner. Well, the new type of positioner is a mix between the initial positioner, the thermoformed one that was good and not adapted to the model, and finally this gave birth to the 3-layer positioner, which is a positioner that mixes the previous 3 layers to make the positioner, but faster than a thermoformed positioner. The first layer is a layer of silicone, very flowable, that includes the attachment with a lot of precision, a lot of accuracy, and it holds the attachment with a lot of retention capacity. The second one is medium capacity silicone, the one we used to use before, except that it now gives the positioner its body. And the third one is a stiff positioner, the stiff layer that provides stability for everything else. First layer, the first silicone layer that includes the attachments, then immediately on top we have the second layer, medium viscosity silicone, and the third layer is a thermoformed layer. We're no longer working directly on the model, we're working on the silicone. So these are the products. The products are Ultradan, Emiluma, and Lumaloc, 2 different levels of viscosity. The first layer with Emiluma, very flowable, very transparent. Choose colored models, because if the model is white, you don't see the silicone. You include the attachments, it goes really fast. You put it around all of the attachments and you leave the model. So we can make several models one by one, and you can leave the model standing vertically so that the silicone will go around the attachments completely and will wrap around. Next, as soon as it's hard, you place the second layer, Lumaloc, a silicone which is very much the equivalent of Lumazil or Regitrans, same texture. And this is what provides the body for the positioner. Again, it wraps around the buccal face, occlusal face, a little bit the lingual face. And if you saw the picture, here there was a gel. The same type of gel that we use for ultrasounds, simply to make the positioner very, very nice and soft with the same thickness everywhere. So we leave the positioner to harden. And once it's hard, then you can do all your positioners for the week. You cut them with a blade to remove excess material because it flows a bit so that your positioner looks nice. And then you remove the attachments one by one. You detach them either with your finger or with a little spatula, and you get the positioner with the attachments inside. You have to remove the repositioner at this stage before you place the last layer, which is the hard one. Otherwise, you cannot remove it anymore from the model. These are the two silicone layers. You place the positioner back on the model, and you make the hard positioner thermoformed. And depending on the machine, you can use different references. I use Durand 0.75, but you can use Ercadur 0.6 or 0.8 millimeters. You thermoform, and then you cut all the excess material away around the positioner, and with very thin and bent scissors, you go all around the positioner and you cut the excess material all around the stiff positioner in order to end up with this kind of positioner. You can remove the two, you separate them, and all you have to do is the little final touches so that you can insert it easily. It's very easy to do with a pair of small scissors, and this is the 3-layer positioner. It's exactly the same that you would use for the technique number 2, and that's why I took the time to explain to you, because it's exactly the same thing for technique number 2.
And then your positioner is ready, and you do the bonding and the clinical transfer. To do that, you have the attachment. You already have the resin stub because you've attached it. This is the situation. You just need to find a material which is compatible, which is hydrophilic, low viscosity. You already have the resin. There should not be excess thickness. It's a dual type setting mode. The texture has to be adapted, and you need to facilitate the removal of excess material. In the systems we are familiar with, you have resins or glues, glass ionomer cements, or self-adhesive systems. I'm not going to ask you to change what you do. It's what you use daily. You have 6 possibilities: either an adhesive and a fluid composite, or a self-etching and a fluid composite, or a glass ionomer, or a self-etching. You have all these different possibilities. And so if you choose method number 1, you're going to etch, you're going to rinse and dry, place the adhesive, and all you do is put the very fluid composite. That's not what you do for the next steps. Or you will put self-etching adhesive on the tooth, and you load the positioner with the fluid resin. This is what you do basically every day. Or you may decide to put glass ionomer, and it's completely compatible with your resin. And you etch with the polyacrylic acid or the other product, depending on what you do usually. And you can use the self-etching one or the glass ionomer. This is what I do daily for my cases. You may use a self-adhesive glue if you wish. With prior etching, you do etching, you load the positioner with the self-adhesive glue, or you have to be careful. All of the self-adhesive glues are not compatible with the self-etching product. I propose this association and no other. It's the Maxim Elite, which can be associated to the self-etching product, and not any other one for reasons of compatibility. So you have 6 possibilities. If you want to know what I do daily, this is what I do. Anteriorly, I put self-etching from 5 to 5 and glass ionomer from 5 to 5, and For the posterior ones, I'm going to etch 6 and 7. I will put a very loaded hydrophilic solid substance and a glue and a composite. And so this respects the enamel in the anterior teeth, and I have excellent retention in the posterior sector. Method number 2, you've been waiting to hear this. You take the impression, you do the virtual positioning, you do the impression of the model, and you print the positioner, and you place it in the mouth. You need the software, which will enable you to position where the brackets go, and there's the treatment. If you don't have the treatment and bracket placement option, you can't do this, but you will have the possibility of printing how to place the positioner. You need the 2 softwares for this technique. How do you do it? It's the same as the previous one for the impression. You've worked on the model. You will need to do exactly this, go through a sequencing. You indicate what teeth are absent. Once you've indicated what teeth are absent, you separate the teeth, mesal, distal, so that the software can recognize the teeth, and then you work on the axes of each of the teeth from a panoramic X-ray. This is not compulsory, but I do this at the office. My assistants do it. It's the indispensable step for me is the next one. So we will be identifying the important morphological characteristics of each tooth, the marginal ridges, the cusps, etc. And then the software will say whether it has recognized the teeth properly. If there's a mistake, you can correct it. And if there's a mistake on the original impression, it can be corrected. It rarely happens. We've never had to do it. The impression is easy to make. Once that's been done, you determine point FA. The software determines point FA from the information it has received. If you don't like that, you can modify it. For each tooth, you're going to be able to check, and you're going to lock, so to speak, the FA points, and you have a library of arcs. And you can choose the arc you wish to use, and you're going to be able to work on the malocclusion or on the setup. You have a choice. And I'm very pleased that I have the genius in our library. We have all the references, and we will be classifying the brackets from 1 to 5. You pick them in the bracket library, and you will do the 6s, and we're going to be getting the 7s soon. And this is where the work begins. The assistant has done all the previous work. I will just come and reposition and check. So I can either I work on the bracket which has to be repositioned, or on the setup. I am able to work on the setup, move the teeth, or enter values here. Every time you move here, it has a repercussion on the bracket. And when you move the bracket, it has a repercussion on the setup. 2 minutes more. So you can work in all the directions, the axis, the rotation, tipping. I had a video. I guess I'm going to skip that. Once you've done everything, if you want to move to the next step, the software can tell you there's an interference, or for the antagonist arch, and you will say, yes, okay, I know it, and don't take that into consideration because I have blocks planned. And there may say there's an interference with the gingiva, so you may decide to change the placement of the bracket. Or you have the hook here, which interferes with the gingiva. I can remove the bracket with a hook and put one without a hook. And here, there no longer is any interference. And if you've forgotten a small interference, the system is going to remind you of that, whether it's with the gingiva or the tooth next door or the bracket next door, which is next to it, it's going to tell you. You may remove the bracket and place it later on because there's a lot of rotation on the tooth. And then either you do an impression of the model or the positioner. You can move from the virtual positioning and print the model, or you can print the positioner directly. There are two versions. You can do it with a template or a marker. This type of model, and you position the brackets, or, well, forget this version because it's a waste of time here. It's as if you were using the first technique. The only thing you need to remember is these parameters that you can play with. And this is what enables you to have a very comfortable, precise positioner with easily placed attachments. And for the one I'm going to be proposing, this is what you should choose as the reference. Series is 1. You can determine the size, etc., insertion, disinsertion. And you have this type of model, which is going to be printed on the raise or a resin printer. Both possibilities exist to produce the same positioner that we saw earlier. And then 3-layer positioner, you insert the attachments in the slot. And it's a little different for the transfer. In the previous one, you had resin. And here, there's a vacuum which has to be filled. So you cannot use the same bonding systems as previously. You cannot use a low viscosity system. You need a medium viscosity system. This is what I propose. What you see up on the screen, I'm terribly sorry. I'm going to have to stop here, and it's just that for the positioner and the pressure, well, this is going to be ready 2 months from now. The only difficulty we have is the change in the parameters that we saw earlier for the printed one. You're going to have to play with the retention, the size of the bracket, so that it can be placed easily. You have to work on it well so that there is no damage in